of trying to break down NZEB and just give you kind of a broad overview on what that means. So I'm going to do my best this morning to give you a better understanding into what NZEB means. As Stephen said, I work at the National Construction Training Centre here in Mount Lucas. We have one of the centres of excellence in NZEB and Retrofit, and I'll talk to you a little bit about that later on. So just, I guess, to give a bit of background in NZEB, first of all, why are we talking about NZEB? Why are we moving towards nearly zero energy buildings? And when I was making this presentation yesterday, I wanted to kind of give you a better understanding, I guess, or a bit of background. So I just grabbed some headlines, all recent. I mean, this one is from November 7th, but time running out to act on climate change. Micheál Martin arriving there at COP27, and we all know that that's happening in Sharm el-Sheikh at the minute. Another one here, again, a recent headline, what climate change report says about Ireland, flooding, heat waves, and when they could happen. So we're all worried about this 1.5 degree Celsius temperature increase and what that could mean for the planet. Again, the 4th of November, this is coming from the IGBC. So carbon emissions associated with the construction, buildings, and infrastructure sector account for approximately 1/3 of Ireland's emissions. So that ultimately is what the main concern is and the motivation for moving towards nearly zero energy. If we look at that in statistics, the construction and built environment sectors account for 37% of Ireland's national carbon emissions. And that conversation is happening across the board. You know, how are we reducing carbon emissions in our transport sector, in our agricultural sector? But we also need to look at the built environment sector there as well.
Go back to Christina.
If we break that down even further, we've got our heating, cooling and lighting in our buildings account for approximately 23% of that. And then the remaining 14% is embodied carbon. And that conversation is starting to become more prevalent now as well. And you'll hear more about that in the future. So I guess, where did NZEB come from, or what's the background on it? Essentially, it's all coming from the Energy Performance of Buildings Directive, which is a European directive originally published in 2002. It was recast in 2010, and then it was recast again in 2018. But essentially, we're hoping to reduce our CO2 emissions by 51% by 2030. And like I've already said, we need to focus on the built environment. We need to aim to reach carbon neutrality by 2050 in order to slow down or stop climate change. We're all very aware of the fact that we're experiencing these unrealistic or incredible weather conditions at the minute. I mean, I was helping my brothers build a shed at the weekend, and I went equipped for November farming, 2 pairs of trousers, 2 hoodies, and I was peeled down to my t-shirt in a matter of minutes because it was so warm, 17 degrees on a Saturday in November. I mean, we're all very worried about what's happening with regards to climate. So essentially, we now need to take more responsibility to slow down or stop climate change. And like I said, we're focusing on the transport sector, we're focusing on the agriculture sector. We also need to focus on the construction sector. So the Energy Performance of Buildings Directive is a European legislation. It was pushed out to all of the individual member states, and essentially NZEB started being mentioned in the 2010 recast. So each member state was given its own ownership on NZEB, and Ireland published these 2 documents in 2019. So Part L, Technical Guidance Document L, and Technical Guidance Document F were both published hand in hand in 2019, and this is essentially where NZEB comes from. So it's the conservation of fuel and energy in dwellings. And then in tandem with that, we need to have an understanding of the ventilation regulations. As I said, they were both originally published in 2019. TGDL has since been revised in 22. Both documents must be looked at together in order to meet NZEB compliance. So what is actually NZEB, and what does that mean for us? And we have this schematic here at Mount Lucas. It's considered to be the 7 steps to NZEB, and I'm going to use that as my basis for this lesson today. So nearly zero energy building is a building that has a very high energy performance. The nearly zero or very low amount of energy required should be covered to a very significant extent by energy from renewable sources. including energy from renewable sources produced on site or nearby. And that's coming from the EPBD. Essentially, it's a comfort standard. So we're trying to build a highly insulated, highly airtight, well-ventilated home that costs very little to run and burns very little carbon. And then we're going to also produce renewable energies on site or nearby. That's what NZEB is in a nutshell. But ideally, we're going to have high levels of comfort in an NZEB dwelling. So the three key targets for NZEB in an Irish context are to reduce the energy performance. And when we're doing that, we're comparing it to the existing housing stock. Most of us live in C-rated homes, D-rated homes, E-rated homes, or even Gs. And we measure those homes using the BER assessment tool or the DEEP software. So we want to reduce our energy performance coefficient, that EPC figure, and our NZEB dwellings should have an EPC of 0.3. That's when compared to the 2005 building regulations. We also want to reduce our carbon consumption dramatically. So our carbon performance coefficient, or our CPC value, should be at 0.35. So we're going to consume less electricity, we're going to reduce our carbon consumption, and then finally we're going to have renewable energies in our houses. So we must have a renewable energy ratio, or an RER, of 20% on all NZEB dwellings in order to comply with NZEB. And that's coming straight from Part L of the building regulations. You'll find EPC, CPC, and RER littered throughout that document. I just took some snapshots there of the BER in case you weren't familiar with the rating system. So it rates houses from A to G. And like I said, it's measured using the BER software, which is called DEEP, the Dwelling Energy Assessment Procedure. So I guess the first measure that we must take in order to reduce the energy consumption in our dwellings is continuous insulation principle. So here I have my house. I have continuous insulation the whole way around my house. I'm going to have less energy escaping through that house. If we look at the second law of thermodynamics, one of those laws states that heat will always move from hot to cold. So what does that mean for us in a dwelling context? Well, if I've heated my house up to 19 degrees, internal temperature 19 degrees, and it's 4 degrees outside, for example, a normal November day, that heat, that thermal energy that's inside in my house is trying to escape however it can. Now, thermal energy will move in three ways. It'll move in convection, it'll move through conduction, or it'll move through radiation. But essentially, it'll escape through one of those three measures out of my house. So I'll have heat escaping through my walls, through my floor, through my ceilings, through my roof, through my windows. However, it can escape through conduction, convection, or radiation. So with my NZEB dwellings, and again, taken straight from Technical Guidance Document L, there are backstop U values that we must achieve in an NZEB dwelling. So you can see there the backstop U values for your roofs, for your walls, for your floors, etc. So 0.18 here, 0.18, 0.16. So we're trying to get our continuous insulation principle. Interestingly, the average U value for our windows is 1.4. So that would be a standard double glazed unit, average U value at 1.4. But our windows form part of our insulation layer. We're talking about continuous insulation principle. We have 0.18s, 0.16s, 0.18s, maybe 0.2, depending on the house type, if it's flat roof detail. And then we have 1.4 here. So, you know, almost 10 times less performing or worse than your insulation in your attic, in your floor, etc. But that's one of the first ways that we're going to double down on heat loss in our NZEB dwellings. The second way that we're going to double down is through air tightness and vapor control measures. So by insulating everywhere, we're going to stop heat loss through conduction, but we still will have heat loss through convection, so drafts. And remember, we're talking about NZEB as a comfort standard. So we want to minimize drafts where possible. So by implementing air tightness and vapor control measures in your house, and that's my red line here, I now have a continuous airtight vapor control layer around my home. And again, taken from technical guidance document L, each NZEB home must have an air permeability level of below 5 meters cubed per hour per meter squared. So how do I achieve that? Well, there's loads of different ways of achieving air tightness, but the most common way in most homes now would be by installing tapes and membranes around your windows, at your floor to wall junction, at your wall to ceiling junction, and at various intervals. You can see two of these pictures here. Some of you might ask, how do you measure your air permeability? Air permeability is measured with the blower door test. And a change in the technical guidance document L since 2019, every new home needs to have a blower door test to determine air permeability measures. So moving on then to the next principle of NZEB, low thermal bridging. And just a note, I guess, a thermal bridge occurs anywhere that there's a break in the insulation layer. So if I have severe thermal bridging, I'm going to have things like heat loss, because there's going to be heat loss through conduction. I'll also have condensation and I'll have mold. But more worryingly, I'm going to have damage to the building fabric as that thermal energy, as that warm vapor laden air escapes to the outside. We don't really want that happening, you know, in our NZEB dwellings. So again, taken straight from the gov.ie, the technical guidance document L, there's a sister document called the acceptable construction details. And within those acceptable construction details, there is a checklist that helps you to minimize thermal bridging. So a thermal performance checklist. There's also an air barrier checklist down the right-hand side. So just to draw your attention to the fact that those acceptable construction details exist, they're free to download. If you just look up technical guidance documents or acceptable construction details, you'll find this whole suite of construction details. So this is your ground floor insulation above the slab, and there will be measures in there to try and minimize thermal bridges and also to ensure that you have a continuous air barrier. We need to have high performing windows because, like I said already, we know that the windows are going to be the outlier. My walls have a U value of 0.18. My windows, standard double glazing, maybe have a value of 1.4. So your windows do form part of that insulation layer, and you must aim to achieve the lowest U values that you can. Typical double glazed window U values, you're looking at 1.4, 1.5 watts per meter squared Kelvin. Typical triple glazed windows U values, you could be looking at 0.7, you could be looking at 0.6 here, but 0.8 would be maybe your standard if you were talking about an average value. So when we're talking about triple glazing versus double glazing, it is just worth considering. Now there are double glazing windows and there are exceptions that are going to have, you know, lower U values than 1.5, please don't get me wrong. But what you're aiming for with windows is there's going to be a combined U value and it's going to have the lowest U value possible, bearing in mind that your wall U value is at 0.18 as a backstop, as a minimum. And then we also have to consider solar gain. So if I have, you know, large windows on the south facing wall of my house, how am I going to prevent overheating in the summertime? So it is just worth considering. Then ventilation is the next measure that we need to consider with NZEB. And there are two ventilation strategies outlined in Technical Guidance Document F. Technical Guidance Document F is the ventilation document that goes hand in hand with Technical Guidance Document L. This is a photo of one of the ventilation units here in the training centre, so your mechanical ventilation with heat recovery system. So the two strategies that were outlined are natural ventilation and mechanical ventilation. Now, how do I decide what ventilation system to install? Well, it depends on your air permeability value. If your air permeability levels are between 3 meters cubed per hour per meter squared and 5 meters cubed per hour per meter squared, you can install natural ventilation. Now remember, 5 is the backstop. That's the absolute maximum that you can have in an NZEB dwelling. Where air permeability levels are less than 3 meters cubed per hour per meter squared, you must install a mechanical ventilation system in your house. Why do you have to do that? Well, because you're building a highly insulated, highly airtight home, we must ensure that you're appropriately ventilating that space. We have one of the highest rates of childhood asthma in Europe. We know that we have poor indoor air quality in premises and homes in Ireland. So there's now a drive on to make sure that those homes and those spaces are adequately ventilated. And technical guidance document F has the calculation methodology to ensure that every house is calculated appropriately. So what types of ventilation systems can I use for mechanical ventilation? So you could have mechanical ventilation with heat recovery, MVHR. You could have a continuous mechanical extract ventilation system, CMEV, demand control ventilation system, DCV, or you could have decentralized versions of these. It doesn't really matter. As long as it's mechanical ventilation, you're ensuring that there are delivered airflow rates and delivered extract rates into those rooms. Every NZEB dwelling must ensure that appropriate calculated ventilation levels are being delivered. It's so important. Every person working in ventilation must be able to prove competency in design, installation, and commissioning of systems. And that's again something that's really important and worth knowing as a homeowner. If I have someone coming to install my ventilation system, I can ask them to prove competency. Are you competent to design that system? Are you competent to install that system? And as part of the LOETB Mount Lucas training facilities here, we actually offer one of the City and Guilds accredited ventilation courses. So WWETB and LOETB currently offer that qualification. And then, so you have somebody who's competent in design, somebody who's competent in installing the system, somebody who's competent in commissioning the system. That system then needs to be independently validated by a third party who's NSAI or INAB approved, and that person is called a validator. So at each stage of install, you have a competent person who is responsible for your ventilation system, and then you need to make sure that it's been validated at the end to ensure that design rates are correct and that commissioned rates are being delivered. So then we're moving on to high efficiency heating and domestic hot water. And this is where your heat pumps come into play. So we had those backstop values for NZEB earlier, your energy performance coefficient, your carbon performance coefficient, and your renewable energy ratio. So your CPC was 0.35. We're trying to reduce our carbon consumption to hit those 2030 targets and 2050 targets. So we need to reduce our reliance on fossil fuels in order to reduce carbon emissions. I live in the Midlands. My parents have a two-story house in the countryside. There is 3 stoves slash ranges in that house, and all of them burn turf and timber. So, you know, in terms of carbon emissions, they'd be quite large coming out of that house. We need to look at reducing our reliance on fossil fuels in order to hit this CPC value. So we're moving more towards cleaner energies, and heat pumps are considered to be extremely efficient because of this value here between 300 and 350%. So the seasonal coefficient of performance of most heat pumps are between 300 and 350%. Now, what does that mean? It means for every unit of energy I use or consume to run that heat pump, I'm converting that into between 3 and 3.5 times that amount of heat energy. So the conversion factor there is between 3 and 3.5 times, which is huge. So because of that, they're actually considered renewable technologies. And what you're talking about is this sort of you could be talking about a ground source heat pump, an air source heat pump, it doesn't matter. But heat pumps are becoming more popular because of the fact that they're so efficient, and they're positively impacting on your BER assessment. Then the final step for NZEB is the renewable energy ratio. So like I said earlier, it's 20%. 20% of regulated load must be produced on site or nearby. That's again coming from technical guidance document L. So your regulated load includes your heating, your cooling, your ventilation, your lighting, and your domestic hot water. It doesn't include appliances, folks. And that's, I guess, because we can't standardize the amount of appliances in any one person's home. But every house we know needs to be heated. Houses in the future will need to be cooled. Houses have some sort of a ventilation loading on them. They also need to be lit, and your hot water needs to have electricity as well. So all of these will have a loading, and they do have an impact when it comes to your deep assessment, your BER. So 20% of that regulated load now must be produced on site or nearby. And there are different ways that you can meet that trigger in terms of your NZEB dwelling. You could use PV panels on the roof. You could have micro generators, so for example, micro turbines, or even a wood pellet stove could potentially go towards that 20% if you were partnering it up with something else. So there is different ways that you could hit that 20% regulated load. But most people, in order to hit NZEB compliance, are partnering a heat pump with solar PV, and they're hitting that 20% very, very easily. Because of the fact that you can now feed back into the grid with your solar PV systems, and you can get paid for the production of excess electricity as well, it's looking more and more appealing to homeowners. So it is one of the variables that's measured on the BER. Like I said, we're looking at EPC, we're looking at the CPC, and we're looking at the RER in terms of the BER assessment. So finally, I just want to give you a note on the actual Centre of Excellence here in Mount Lucas. So it's a simulated training facility, and here's some pictures. So we have external wall insulation rigs, internal wall insulation rigs. We have a fully fledged bungalow here that people can retrofit. And we have attic rigs as well. We've got ventilation bays, airtightness rigs. There's loads of stuff happening. Fully funded courses through the Skills to Advance funding mechanism, and training has been developed with the Department of Housing, the NSAI, the SEAI, CIF, and industry stakeholders. Our qualifications are either City and Guilds assured, they're QQI awards, or they're industry recognised that we're moving towards QQI certification. If you want to know more about NZEB, we offer a one-day course on NZEB. It's City and Guilds assured, and you can also use it to get CIRI points. So if anyone is interested in that, I've just popped my email address down there. And that's it from me, folks. Hopefully that wasn't too overwhelming, but that's